So we want to figure out their distance, right? So the distance, so this is Karen's stuff, right? So when we integrated the absolute value of the velocity right here, that gave us the total distance traveled, right? How much she actually rode. But if I want the actual distance from school, then that's just going to be the integral of velocity. Okay. Does that make sense? Which means that, what do we get for that? Total distance. So she was at home, she left, she came back home, she was at home, and then she left again, right? So couldn't we just go from here to here? Okay? Because these two things zero out. I mean, we're technically getting all of that, but they zero out. So if you add all that up, you should get 1.4 miles. And then the other one that they gave us, what they call it, W of t? Yes, W of t dt. Okay? And if you put that in the calculator, like I told you to do on your own, you get 1.6 miles. So, and then the question said, who lives closer to school? So here's your work, and then Karen lives closer to the school. Okay, we good? What questions you got? All right. So here's what you're going to do now. I want you to look at question number 4, the one before this, 2006. I'm going to give you 25 minutes to work through this on your own. You can talk about it amongst yourselves at your table. So if you want to move over here, that's fine. Okay. Rocket A has a positive velocity after being launched upward from an initial height of 0 feet at time t equals 0 seconds. The velocity of the rocket is recorded for selected values of t over the interval from 0 to 80 seconds as shown in the table above. It says to find the average acceleration of the rocket over the time interval and indicate units of measure. Okay, they gave us velocity. They're asking us for average acceleration. How is acceleration related to velocity? It's the derivative because it is the what of velocity without using the word derivative. The rate of change. Acceleration is the rate of change of velocity. So it's asking us for the acceleration, but I want the average acceleration, so I can put a little subnote here, which means it's going to be an estimate, right? Okay. Average acceleration from 0 to 80, and so that's going to be v of 80 minus v of 0 over 80 minus 0, right? So that means that gives me 49 minus 5 over 80. And you could just leave it like that, and that's fine. Can't leave it like this, but you can leave it like this. But then we need units, right? Because it says indicate units of measure. So my velocity, this is feet per second divided by seconds. So again, you could do feet per second squared if you wanted to, but if not, that is just fine right there. So in this case, you just got 1 for the answer. Sometimes units make a difference, but the unit, I didn't print out the second page, which gives the specifics, so I'm not sure if you would get that knocked off if you didn't have the right units or not, if that was actually something they were looking for real. Okay? So then on B, it says using correct units, explain the meaning of that integral in terms of the rocket's flight, and use a midpoint Riemann sum with 3 subintervals of equal length to approximate that. All right, so it first says to explain it, not that you have to do it in that right order, right? But if I was going to, right, I could say 10 to 70 b of t dt. All right, what is it? No? It's the total distance, yes. You.
So every time I listen to him, I get it wrong.
Okay, because y'all were talking displacement, right? Oh, okay. I'm with you. The total distance, all right. So it's not the total distance, you're right. It's not the total distance. It is the displacement. It is the distance from the starting point, right? The distance the rocket is from the starting point. Does that make sense? Yes? Okay. Let me tell you why can we both be right? When is distance and total distance and displacement going to be the same? Okay. If we look at this one here that we did, right? The total distance traveled and the distance from her house are not the same thing. Why? Just tell me in terms of the question. Because she turned around and she went back, right? She left her house, then she turned around and went back, and then so we had a negative velocity in there sometime, right? Do we have a negative velocity here? So in this particular case, if you said it is the total distance the rocket traveled, that's fine. If you said it is the distance the rocket is from its starting, or from the distance that the rocket is from its placement at 10 seconds, or however you wanted to say that, that would be correct also. All right? But because it clearly says, now, it's not just because I only have positive velocity here. It's because it says it has positive velocity after being launched upward. Okay? And that it's telling me that. So it is fine in this case to say it is the total distance. Do you see that one? Okay. So really either one would have been right in this case. So we can say that this is, I think it's a little easier to explain the total distance, so I think that's one. Is total distance traveled in what units? In feet. Okay, the distance is in feet. The total distance traveled in feet. And I don't remember what the rest of the question said. What I wrote. What I wrote was the total distance is the distance in feet, rocket A, and yours doesn't have to sound exactly like mine, and I'll read you what the other thing says too. Rocket A traveled from t equals 10 seconds to t equals 70 seconds. Okay, let's see what the actual thing says. It says since the velocity is positive, v of t, the integral represents the distance in feet traveled by rocket A. Okay, it's almost exactly what I said. So you have 1 point for the explanation. Okay, then we have to actually do the Riemann sum, right? Use midpoint Riemann sum, 3 subintervals. So that's 1, that's 2, that's 3, right? So this gives me 20. Oh, does it? Oh, shoot. Thank you. Thank you. Wait. Oh, yeah. Yeah, you're right. No wonder. I was like, that's how I would split it up. Thank you. Did I do it right? Oh, I actually did it right when I really did it. So on my own. Thank you, though. Wanted to see if you were paying attention. 10 to 30, 30 to 50, 50 to 70. Yeah, sorry. So then this is 20. This is 20. This is 20. We good? Yes? All right. So then I can say that the integral from 10 to 70 of v of t dt, what comes next? Squigglies, right? Squigglies, because we're approximating, right? So then let me look at my paper instead of scrolling. So then I have 20 times what? 22. And then I plus 20 times what? 35, because it's the midpoint, plus 20 times 44 feet. Is this feet per second? It is velocity, but I integrated it. When I integrate velocity, I get distance or position. It's the total distance. Because look, we just said that when we integrated that, it's the total distance traveled in feet. So this is, that looks like FF, but that's a T. Okay. Good? All right. So here's how these points worked. You got a point for the correct explanation. You got a point for, so it says uses V of 20, V of 40, and V of 60. I guess that you used these correctly. That's a point. And then a point for the actual value, which doesn't mean that you have to actually like solve it out, but that you kind of get 2 points for that, basically. This is one of those things where they said, like, when you do the Riemanns, if you had messed up on one of these, then you get the point for doing the Riemann sum correctly, but you don't get the actual value point on it. Okay? How are we doing so far? Not bad? Okay, doing great. All right, now we're looking at C. So C says, rocket B is launched upward within this acceleration, feet per second, at time t equals 0 seconds. The initial height of the rocket is 0 feet. Initial velocity is 2 feet per second. Which of the two rockets is traveling faster? Explain your answer, which means we have to find these things, right? Okay, so rocket B, if I want the velocity of V of t of rocket B, how am I going to find that? I have to integrate this one, right? And so when I rewrite this, I think I want to write it as 3 times t plus 1 to the negative 1/2 power dt. Okay, do you agree with that? Okay, so then we are going to integrate. When we integrate, I'm going to still have this 3, right? I'm going to add 1 to the 1/2, to the negative 1/2, which makes it a positive 1/2, right? Then I divide by the positive 1/2, which means I multiply by 2. And then this is t plus 1 to the 1/2 power. Then what else do I need? Plus c. Okay. Now I need to figure out what that actually is, right? So do I have an initial condition? The initial height of the rocket is 0 feet. Okay, well that's good. So that means that this equals V sub B of t. So that means that 0 is equal to 6 times 0 plus 1 to the 1/2 power plus c. Ooh. Uh-huh. Okay. Everybody with me? That's 0 plus 1. 0 plus 1. I forgot my 1, so I put it in there. That's 0 plus 1. So that's 1. The square root of 1 is 1. I get 6. What does c equal? Negative 6. Yes? All right, so V sub B of t is equal to 6 times the square root of t plus 1 minus 6. Do we all agree with that? All right, so let's look at our scoring right now because I know the bell's about to ring. We would get, where'd it go? We get 1 point for having this. We get 1 point for the constant of integration, that's this. And we get 1 point for using the initial condition. And then you still have to have your units in the end and find the rest. We'll finish this tomorrow, okay? We good? Did y'all do okay on this, kinda? Yes? Maybe? Sort of?